Hello everyone and welcome back to my channel. Today we are going to discuss about a new chapter, that is work, energy and power. So as in the last video we have discussed about the cell part. So this is the USD physics part we are going to discuss. That is the first chapter we are going to discuss is work, energy and power. So by this chapter we can relate to our daily to day activities and life, which or the works we do in day to day life. So what are those? The first thing is, suppose you are going to school. So you carry a school bag, bag which like arm straps are there, which you carry on the back, a backpacks we call backpacks or school bags. So when you carry the backpacks, you are moving. So by the carrying of the backpacks, you are going to the school from your home. So you're doing a work. We call it we are doing a work, or sometimes we say do this work. That work means what today's video we're going to discuss that what exactly work is, like in physics language. So why did I say that physics language? Because physics language work is a bit different thing to me. So as you can see, this man doing a work. How can you tell that this man is doing? He is putting a pressure, a mechanical force has been applied by this man, by his hands, biceps, triceps. So, and the object is moving from its initial to its next position. It is getting displaced where it belongs. Suppose that box belonged here. The man exerts pressure, force, then the box found itself here. So by the terms of two things, in case of work, we need two things. What are those? That is force and displacement. Is the object got displaced, and towards the displacement should be towards the force. That means he's applying the force, he's pushing it. That means he's moving towards the force. And if we pull it, then also if we pull it towards him, then we'll be against this direction, isn't it? So that means what? Displacement towards the force, that is important, and force is always important. Force, if you don't exert force in any object, work done. So, and this chapter is about work, energy and power. So these three things are related. How? If you are doing a work, you need some energy. In the cell part, USD cell part, we have discussed about the what is energy. Sorry, mitochondria, cell organelles we have discussed. So what is the function of mitochondria? It produces energy, ATP, adenosine triphosphate. So same thing, we need energy to do certain work, and to do certain work we need some power to exert on it. And they have different types of SI units. Suppose the SI unit of work is joule, and so do the energy. Energy is also joule, but power has a different, that is watt, capital W, or joules per second. Joules per second, or simply you can write like this. But in case of power, mainly it is used watt, but joules not in. Okay. The first thing, today's video we're going to discuss that only one thing, that is what is work. I am divided these parts as it is physics. I have divided the videos in small parts so that for you guys to understand. The next is, first we need to understand, that is what is work. The work is said to be done by a force acting on an body or object only if it displaces. The same thing I have told, that if displaces from its initial position, displaces the body along the direction of, I say the direction of force is important. This man is moving, doing a work along the direction of force. The definition is some points you have to use. That is the red part that is highlighted, the direction of force and displaces. If these two words is there in your work definition, suppose someone asks you in the examination comes that what is work. If these two things comes na, if you have written in your exam copy, each and every physics teacher and you have to give you full marks, because in physics such terms are used. Terms, if you use it correctly, appropriate position, no concern for you to get deducted in, like suppose it's a 2 marks question, you will get 1.5. 1.25, 25 or 1.5, whatever. So in this way, if you write like this definitions in case of physics, the one thing is important, that is definition. Definitions should be appropriate, and you have to make understand that invigilator that you know about something about physics. You need to make sure that. So next is let's do a sum. So what is a sum? So before doing the sum, in the work part there is a definition of work. Now in case of any sum, someone asks you what is the work done, work done. So work done has a formula, that is W equal to Fs. Now from where, now I have told that joule, the SI unit or standard unit, universal, which is used for work done everywhere in the world. If you go to the any corner of the world also, there is the SI unit of work is joule, and everywhere the SI unit. So W equal to Fs, that means force and displacement. Force equal to displacement. Work done equal to force into displacement. This is the formula. Very easy. I have told that if you are doing certain work, suppose I am pushing something, then I have to exert force on it and it is getting displaced. The same thing, just multiply it, the work done will be on your hand. So from where this joule comes? So here look, W equal to force, the SI unit of force is Newton, and the SI unit of displacement is just distance or displacement. So W equal to N into M, that is Nm, or W equal to Nm equal to joule. So we can say that W equal to joule, Nm equal to joule. 1 Nm equal to 1 joule. Here 1 Nm equal to 1 joule. That means 1 watt equal to 1 joule. So the SI unit of work is joule. In case of question comes that how you can prove that SI unit of work is joule, or simply capital J, you have to write like this. Like this thing you have to write. So next part is our let's do a sum to make it a bit more interesting. And in physics, the most important thing is not definition, sums or the mathematical calculation, which if you go to higher studies, in most important thing will be this sums and mathematical calculations. So next is, first question is, how much work is done by a force of 10 Newton in moving an object through a distance of 4 meters? So our sum is, what is the force given? Force is 10 Newton. And what is the distance given? That is 4 meter. Everything is in SI, so we don't need to convert anything. Meter in distance meter is okay, and force equal 10 is okay. If this was given in dyne, then CGS2, and that is a different thing. And we can also calculate in dyne also, the CGS of force, CGS unit. And the CGS full form is centrifugated system. You don't know, because this types of question come in CP. That what is the full form? Yes, centrifugated system. So our first is work W equal to, you know the formula, W equal to Fs, or equal W equal to here. And one thing, the most important thing, to do the sum correctly, still you will not get full marks, because you have to write like this. Here you write W equal to Fs, don't start calculating. You have to give a third bracket and say here F equal to force and S equal to distance. You have to write like this. Next, W equal to force is 10 Newton. 10 into 4. W equal to 40. 40 joule. Don't write Newton meter. Write joule. Joule would be a better, what do you say? Cute. If you write 40 joule, this is the answer. Answer equal to 40 joule. That was sum. It was very easy. Just 4 ones are 4 and the 0 comes 40. We have to use the formula in appropriate position. There is another formula in our work chapter, that is W equal to Fv. That means there is no distance given to you, there is force given to you, but there is one thing given, that is velocity. Don't go jump into the method of initial velocity, final velocity by time, you have to find acceleration. Don't. Just do it simply that this formula is there. W equal to force is suppose 60 and velocity is given 2. So W equal to 120. Simply do this. If velocity is given and force is given, use this formula, that is W equal to Fv, and if distance is given or displacement is given, that is W equal to Fs. These two formulas we have discussed. Next is factors affecting the work. This is the last topic we are going to discuss. As I said, I have divided the video work chapter, work energy and power chapter, different types of multiple points or videos, that it will be easier for you guys to understand. Is the factors affecting the work. So what is the factors? Two factors affecting the work. What are those? Magnitude of applied force. Work is directly proportional to the magnitude of the force. How? See, if the work done is doing, if some work is going on, then the force will be involved. And if force gets suppose 10 Newton, it exceeds to 20 Newton, then the W will be more, isn't it? So that means directly proportional. If it is inversely proportional, that means if force gets more, better force is more, then the work done will be less. But in this case, F into S. If F gets, suppose S is suppose 2, then if F is 10, then the work will be 20. If it is 20 Newton force, then the work done will be 40 joule. The same thing, if the work force gets more, the work done is more. So you can say that work is directly proportional to the magnitude of force. And next is that is our displacement part. So what is displacement part? So in this case also the work is directly proportional to the force. Sorry, it will be displacement. So magnitude of displacement, work is directly proportional to the displacement. How? If same example, if force is 10 Newton and displacement gets 4, then it would be 40. If displacement gets 5, then it will be 50 joule. So as the force is also increasing, the work done is increasing. That means force is directly proportional to the work done. And if displacement is also increasing and the displacement is also increasing and the work done is also increasing, that means displacement is also directly proportional to the work done of an object. These two factors affect the work. If displacement gets lower, the work done will definitely get lower, because it is directly proportional, not inversely. Because inversely means opposite, directly means same. If it gets more, it will get more. If it gets less, it will get less. But inversely, if it gets more, it will get less. If it gets less, it will get more. So directly means. So this was our video. Next day we are going to discuss that when the work done will be 0. I will give you a simple use your brain, this common sense, that if the Newton, suppose if you're pushing a wall, then what will be the result? Displacement will be 0. So our formula is W equal to Fs. W equal to F equal to suppose 60 Newton. You're pushing a lot of pressure on it, lot of force on it, and equal to 0. So W equal to 0. So work done is. Next day we are going to discuss the negative work done, positive work done. A lot of things I have to do. Pendulum examples are there. A lot of things. This was the introduction video and a little bit introduction on our work part and the factors part, and we did a sum. It's very easy. Next day it will be a bit harder sum we will do. So hope you have enjoyed the video. I will meet in the next video. Thank you very much.